Okay, so first of all, welcome to everyone. This is the first of our webinar in a series of several webinars where we will cover topics related to contactless measurements in hydrology. My name is Nikša Orlić and I'm a co-founder of Geolux, which is a company that produces radar-based sensors for water level and surface velocity measurement over the past 7 or 8 years. I'm going to share my screen with the presentation now, and then we can start the, just a moment, I'm a little bit lost, sorry about that. Anyway, if there are going to be any, if anybody has any question or something is not clear, please type immediately or whenever you want to the chat, so we will answer questions from the chat. We will not have standard Q&A session at the end of the webinar, but we are going to answer all questions that are posted to the chat. Okay, so radar sensors are used for water level sensing over the past maybe 10-20 years. And recently, with the advances in the technology, in the radar technology, it is possible to create very reliable, very accurate sensors that are not expensive. One of the benefits of these sensors is the fact that they use a contactless measurement method. So the installation is very simple. You do not need to enter inside the water to install the sensor. You just you install it above the water. The sensor is not in the contact with the water, so it cannot be damaged by water. It cannot be damaged it cannot be damaged by the debris which is floating in the water or the sediment which is inside the water, and so on. So the benefits in simple installation and low maintenance are really something which is converting, let's say, people to this contactless way of measurement of water level. However, because of the technology of the radar, it is very important to understand how it works. It is important to understand its advantages. It is also important to understand what kind of problems one can expect when installing or operating this kind of instrumentation, and this is what we are going to cover in the webinar. In general, the radar level sensor works by transmitting a radar beam from the radar to the water surface, and then the radar beam is reflected back from the water surface to the radar sensor. And the radar sensor measures the distance from the sensor to the water by measuring the time which is required for the radar beam to propagate from the sensor to the water and back. There are two types of radar level sensors. The simpler type is a pulse radar, which transmits a very short burst of radio signal and really measures the time of the travel. More advanced is the frequency modulated continuous wave radar, which transmits over some period of time the frequency which is modulated, and then the radar measures the time required to travel this distance by measuring the difference in transmitted and reflected frequency from the water surface. The benefit of using frequency modulated radar is that it uses slightly longer transmissions, so it is less prone to short interference bursts, and also it is simpler to achieve higher accuracy with this kind of the radar sensor. Some of you may be familiar with the ultrasonic level sensors, water level sensors, which also measure the traveling time from the sensor to the water and back. But the ultrasonic sensors use sound waves, so ultrasonic waves, to do this measurement. There is a difference which is important, and that is that the sound waves travel at much lower speed than the radar waves, which travel at the speed of light. And also the velocity or the speed of the ultrasonic waves is changed by the air density. The velocity of radar waves is just very slightly, it's negligible. The change related to the radar, to the air density or to the air humidity is really negligible. And this is why the radar level sensor does not need to be temperature compensated, and the ultrasonic sensor needs to be temperature compensated. You need to know the density of the air, which you estimate based on the temperature, which you can measure. And you need to do this compensation in the ultrasonic sensor. However, this works well if the temperature between the sensor and the water surface is constant. But if there is some, if it's not homogeneous, for example, if it is colder close to the water and warmer near the instrument, then this compensation is not going to be correct, and you will see some loss of accuracy of measurement. Now, the question is how to install the radar level sensor to get the measurement of the water level. The radar level sensor needs to be installed perpendicularly above the water surface. You can use an existing structure, or you can build your own structure to the installation. On these two pictures, you can see how on the left picture some existing footbridge was used to install the radar sensor. And on the right picture, you can see that an existing pipe which goes also above the water was used to install the sensor. There are some things to keep in mind, and one is that you want a structure which is not vibrating or moving a lot. So if it is vibrating, then when you use the radar level sensor, you need to turn on some filtering capability of the sensor to filter out the change of the level that will be measured due to the vibrations of this structure. Also, you want to be sure that the structure is not moving itself. So if you have a very long metal bridge, due to thermal expansion, it can be expected that this bridge will move. So if you can choose between metal bridge and bridge built from concrete, it's better to go to bridge built from concrete. If you have to install the radar sensor at the metal bridge, and this bridge has some pillars that go into the water, then install the sensor as close to the pillar as possible, so that especially the pillar is made from concrete, to minimize this change of distance that will happen due to thermal expansion of the material. Of course, if you have an existing structure, then the installation itself is very simple, because the technicians just need to prepare some holder or mount. They need to come to the existing structure. They do not need to enter the water. They install the sensor, make sure that it is leveled, so it's perpendicular to the water surface, and that's it. From our experience, installing the radar level sensor on a bridge, for example, if you have prepared the mounts, it is something that takes between 15 and 30 minutes. In some other cases, you need to measure the water level at sites where you do not have a bridge, and then you can build some support structure like the one in the picture. The good thing is that the level sensors, the radar level sensors, are not heavy, so that when they are placed on an extended arm like in the photo, this arm does not need to be able to carry high some high weights or some really heavy objects. So it's not expensive to manufacture. It's simple to set up. You need to have a good foundation, which can be just created by pouring the concrete. And you can, so this structure is made from aluminum, powder coated aluminum. And also the installation on site, once you have the base made, is something like 1 or 2 hours for everything. Also, what is important in these cases is to be sure that the wind, if the wind blows, does not introduce vibrations to the structure. So you need to be aware if there is if this is installed on an area with stronger winds, the structure, of course, needs to be stronger. Another picture of a custom build arm. This one is longer, but also the principle is very similar. There are also some specific cases. In this photo, you can see the level sensor, which is attached to the ceiling or to the bottom of the bridge. So it was not installed on the edge of the bridge, but beneath the bridge. This is a specific case, but it is also something that can be done. One of the important parameters of the radar level sensor is the radar beam width. Wider radars see bigger area on the water surface. The radars with narrow beam, they see, you can really pinpoint the area which is scanned. This is important for several reasons. One is that with the wider beam, there is a bigger chance that the radar will not only scan the surface water, but also maybe the shore if the water level is very low, or some of the nearby structures. With narrow beam width, you really know when you install the radar sensor that the beam only hits the water surface. This is important when installing on the side of the bridge. You need to be sure that the radar beam does not hit, for example, some pillars or the structure itself. When you check the market of the radar level sensors and some radar level sensors that have wider beam, the manufacturers usually recommend to move these radars away from the bridge, maybe for 1 or 2 meters. With radars that have narrow beam width, you can really place them very close to the structure, to the bridge, for example. It will not introduce any kind of errors. The installation is simpler, and even with such installation, you further minimize the effect of vibrations. Positioning of the radar level sensor and the tilt angle is very important. As you can see on these 2 pictures, the radar needs to be mounted perpendicularly above the water surface, because if it is tilted, then the distance measured will not be correct. Not only that you will have an offset, but you will also have it will be scaled by the cosine of the angle of the tilt. So also it's important that the radar level sensor, that it's properly positioned, either by measuring the tilt angle with some external tool, or radar level sensor that have internal tilt angle. They can just report this angle, and then after installation you can read the parameter and be sure that it's positioned correctly. Another thing which it is very important to watch for are the obstacles. The radar should be positioned so that it sees or scans the water surface, the clear water surface. If there are some obstacles, for example, like rocks or vegetation protruding from the water surface, then the radar sensor it is not certain if it will measure the distance to the water or to any of these objects. It depends on the amount of radar waves that are reflected from the water surface compared to the radar waves that are reflected from, for example, a rock which is protruding outside, or the vegetation. And this can be tricky because it can change. For example, when the rock is dry, it is not highly reflective to the radar beam, and if you have dry rocks protruding from the water surface, the radar sensor will most likely correctly measure the distance to the water. But if you have a rain, which makes this rock wet, or the water is spraying the rock and it is wet, now the wet rock becomes highly reflective to the radar beam, and then the radar could report the distance to the top of the rock instead the distance to the water. The same thing is with vegetation. If it's wet from the rain or from the mist, it is highly reflective to the radar beam, and then in those cases, the radar sensor will not measure the distance accurately to the water. It will measure the distance to the vegetation. We in GeoLux are aware of these problems that happen in nature, So we are a company that produces radar level sensors to be used for environmental monitoring, not for industry. We highly understand the difference between industrial uses and environmental uses, and our radar sensors have different types of operations. So even if you have a situation with the vegetation protruding from the water or rocks protruding from the water, you can configure the radar to use a different scanning mode, or it's called peak detection mode, which will allow the sensor to correctly report the distance to the water, even if the radar sees only a small part of the water beneath the vegetation or the rocks or something else. So it's also important to be aware of these problems. You may also think maybe that this is not a huge problem for your case, but during the drought periods when the water level is very low, and if you are monitoring a stream which can become very narrow, you will have rocks for sure protruding from the water, and if the radar is not able to distinguish between the rocks and the water, you will have an incorrect reading. Another effect which is important to understand is the scattering of the radar beam from the water surface. If the water surface is ideally flat, then most of the radar beam will be reflected back to the radar level sensor. If there is some surface roughness or waves, then some parts of the radar beam will be scattered away, and the radar will lose the amount of reflected signal, and now the radar sensors, they compensate this effect using different methods, either by increasing integration time internally or by automatically adjusting the internal gain levels and so on. So also this is something that the radar normally handles internally, but in some cases, but if possible, when you install the radar sensor, and you can choose between, maybe you have a bridge over the water. On one side of the bridge, the water is smoother. On the other side, it's more disturbed, turbulent, maybe has some bubbles. You would always want to pick the position where you have as smooth water surface as possible. This is the kind of situation that you really want to avoid. We have seen several times when we installed our units for the customers selected a site where there is some small waterfall. Maybe it's even not a waterfall all the time during the day. So if the water is high, then the water level is same on both sides. But when the water level is low, you have something like this. Again, depending on the position of the sensor, if the radar beam is wider, it will see both the left higher water and the right lower water. It's now the question what the radar will report. With narrow beam, you know what you are seeing, and especially if you use an advanced sensor like the one that we produce, you can also change the different type of the peak detector, so you can be sure, for example, that you always measure the lower, the water in the lower part or the water in the higher part of the waterfall. But in general, all of these problems can be easily avoided by proper selection of the monitoring site. Geolux radar level sensors. So Geolux is producing the radar level sensors for 6 or 7 years. We have installed many of these sensors directly, and even more of the sensors were installed through our partners who we have supported. So our product portfolio includes the level sensors that can measure the water level at distances up to 8 meters, up to 15 meters, and up to 30 meters. And also for each of these three distances, you can choose between 1 sample per second scanning and 10 samples per second. For normal use in river monitoring, 1 hertz or 1 sample per second unit is more than enough. But for oceanographic applications and wave measurement, you need to have 10 hertz version, so that you can also measure wave parameters such as wave height, periodicity, and so on. The accuracy of the Geolux radar sensors is ±2 millimeters. The beam width is 5 degrees, which is narrow. It is narrower than most of the comparable sensors that are available on the market. And it also supports a wide variety of communication interfaces such as SDI12, Modbus, proprietary protocol over serial, standard serial RS-232 port, and analog output 4 to 20 milliamps. So this allows you to connect Geolux sensors with any kind of system. If you have an existing data logger, you need to expand an old station with the radar level sensor. So this is really something that can be easily done. And as I have already mentioned, Geolux radar sensors support some of the advanced parameters, like setting of the active zone. So this allows you to, if you install the radar sensor above the water and you know that the maximum distance, so that the distance from the sensor to the river bed, to the bottom of the river bed is maybe 5 meters, and you are using 8-meter radar sensor, you can limit the active zone up to 5 meters. Also, if you know that the water level will never be higher than maybe just 2 meters from the radar sensor, then you can configure the active zone to start measuring only at 2 meters, not from the radar sensor, but only at 2 meters. This will also reduce some potential artifacts, like what we have seen, for example, is some birds like ducks on the water or flying. So sometimes some peaks in the data, measured data, are introduced from outside factors. You can easily remove this if you know the maximum and minimum possible water level, and you can adjust the active zone. Geolux radar sensor also supports multiple peak detector types. So there is a default detector, or the detector that works well if there is some vegetation or rocks protruding from the water. Also the advanced data filtering, sorry about the typo. So this should be advanced data filtering. There are 4 different types of filters implemented: the moving average filter, the no filtering, the infinite impulse response filter, and also the standard deviation filter, which first removes the outliers and then calculates the average value from the remaining values, also the median filter. And the window length of the filtering is easily adjustable. It can go up to 300 samples, the window length. Also, the sensor supports low power operation to reduce the battery usage. It's operating from the battery and the solar panel. And also, in addition to the measured value, the radars also report some diagnostic information, like the internal temperature, which can be useful if you're installing it in a hot climate to make sure that the temperature never exceeds 85 degrees, which is the upper limit for the operation of the unit. It also reports the signal-to-noise ratio of the signal, so you can be sure that the readings are good. It reports the standard deviation of the data in the filtering window. It also reports the filtered value and the raw reading value. So really, it gives you everything that you need, not only to accurately measure the distance to the water or the water level, but it also gives you a lot of diagnostic tools that you can use to easily troubleshoot the sensor if there are some problems. So we have arrived to the end of this webinar. I really tried to keep it short because I'm aware that you are all very, very busy. Here are the contacts, my email and Tibor's email, that you can use to contact us if you have any questions. Also, if you would like to discuss anything related to radar level measurement with us, we would be very happy to schedule a conference call with you. And also, Geolux is going to be exhibiting at the Meteorological Technology World Expo, which we hope is going to be held in October 5th, 6th, and 7th. So this, of course, depends on the situation with the COVID pandemic. But the latest information that we have from the show organizer is that the trade show will be organized, and it's possible that it will be required for the attendees and participants to either be vaccinated or to come with a negative test. But of course, we look forward to this trade show, and if you are going to be visiting the trade show, also please visit us there. So thank you all. We will be sharing this presentation with you by email. Tibor, are there any questions?
No, there are not any questions here.
Okay, so if somebody has questions, I will not directly immediately terminate. We will wait for maybe 1 or 2 minutes. And if that's no questions, okay, then really thank you very much for your time. I wish you all, I see that Tomislav is typing a question, and Marketa, so we are going to wait for these questions. Okay, Tomislav, you're welcome. It was really nice to have you here. Okay, we'll wait a little bit more. I will also announce the next webinar. We still do not have a date because of the summer vacations, but during the next webinar we are going to cover things related to the discharge measurement based on the surface velocity or index velocity method. So Geox also produces the radar sensors to measure the surface velocity, and using this other kind of instrument it is possible to calculate the discharge or the flow in rivers, and our next webinar is going to cover that topic. Okay, Marketa, thank you very much for your comment as well. And if anybody has any other questions, please feel free to email us. So once again, thank you all for joining, and have a nice day. And bye.
Bye-bye.